Alright, hello everyone, this is Mr. Croach. I'm going to give you some help on the vector story problems. All the answers are up here, and all the problems are basically the same. It's a matter of drawing the vectors, and if we look at number 2 here, we have a vector here going at 40 degrees and a larger vector here going at negative 73, and we add the two vectors and we get a result. But we can't add them in this notation, so we have to switch them to components, and that's cosine, sine. So we add them here, and we do this math, and we multiply. Well, let me go ahead and show you how to add those first ones. Let's make sure we're in degrees. Well, let me put it in degrees. Whoops. Calculators in degrees. And I simply go 200 cosine 40 plus 700 cosine negative 73, and that's going to be that component right there, 357.87. And then if I do the same problem and I change it to sine and just put a sine in there and add these two, I'll get that number. And once you have those, you can find the magnitude if needed, you can find the direction if needed. But always remember, this does not give you the angle you need. Sometimes you're going to have to think about what quadrants it is, add 360, add 180, change it to bearings, do whatever you need to do. Magnitude's the easy one. Magnitude's going to come out. This one's not. Alright, so when you have a problem like this that talks about a plane plus the wind is the result, it's simply you add the two vectors and you get the components. Add the two vectors, get the components. So you'll have to put that in there here and here. And you're going to take the plane, and the plane leaves going northernly, so you can assume it's straight north. And there's the plane. And the wind is northwest. You can assume that's right in the middle, so there's the wind. So the plane plus the wind makes the result. So what's the plane? The plane's at 500, 500. And the wind is at 60, 60. But what are the angles? Now the angles I have on here right now deal with the bearing. But when you switch to cosine and sine, you can't use these degrees. You have to think of this as 0 degrees, 180 degrees, well, 90 degrees, 180 degrees, and 270 degrees. You have to get rid of those bearings and put in unit circle stuff. The same stuff we've been doing since the first week of school. You have to use these. So now the plane is facing 90 degrees. And the wind is facing, well, what is in the middle there? 135? 135. You have to do those angles. That will make it work. And then you do this. Do the magnitude and theta. And I'll give you a clue. The magnitude's going to come on the test tomorrow. There's only going to be one problem with bearings on it. And if you get stuck, the magnitude's always going to work, no matter what you use for the degrees. Whether you use the bearings or the unit circle, the magnitude will work out. So if you get stuck, do the magnitude, you should be fine. The tangent part, that's going to be what's tricky here. So try and switch it to the unit circle, and then once you get an answer, it wants the answer back in bearings. So this is going to give you a unit circle answer. And then what you're going to have to do is draw the angle on here and figure out where it is on the unit circle. I'm going to do one practice problem. This is not the right one, but let's say I do inverse tangent of something, and it tells me that my angle comes out to be, let's say, 200 degrees. Well, everybody in here knows what that is. It comes out to be right there. Right? Whatever it does, it tells me my angle's right there. It'll probably tell me that this is 20. And then I just go 20 plus 180 and I get up to 200. But let's say I'm here on the unit circle. Well, what is that in the world of bearings? Well, here's how you figure that out. You draw that same angle, 20, but we want to know where it's pointing. Well, you put your measurements in here: 0, 90, 180, 270, 360. And then look, this is going 180 plus 200, or sorry, 180 plus 20 gets me to 200, which is on my way to 270. You see how that works? But look what's happening here. I'm going 270 down 20 to 250 because I'm going down to 180. So in the unit circle, which is over here, I am going up to there, but in bearings I'm going down. I know it's in reverse. It's just because this one goes clockwise and this one goes counterclockwise. But draw this angle, put this 20 in there, and you'll be able to figure out what it is. So these problems are tricky because they tell you the problem in bearings, then you switch it to unit circle, then you have to switch it back. If you get stuck, the magnitude will always work out. Make your best guess on this one. Alright, so again, that's the same one here. On this one, number 4, a motorboat in still water maintains a speed of 12 miles an hour, so it's going straight across at 12 miles an hour. But then the river is flowing, we're going to say it's flowing north here, and it goes up by 4. So what is the true speed of that boat? Well, look at what we have here. A right triangle. 12 by 4, and you could use magnitude. A squared plus b squared equals c squared, and to get theta you could do inverse tangent to get that angle. Alright, on number 6, you have 3 forces. A plus b plus c makes a result. And just remember, when you're doing these, you have cosine, 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 sine, sine, sine. Draw all 3 angles and you'll figure it out. And this does not talk about bearings. So you are safe to put in here these angles. The first one is 150, 220, and 350. You're safe to do that. And again, if it has bearings on there and you just want to use those numbers, you'll get the magnitude right. You might just be off on that one, and it'd be better to get the magnitude right than neither of them right. So hope this helps. All the answers are up there. Every problem is done by adding them. That's how you find the magnitude. That's how you find the direction. Just remember, this doesn't tell you exactly what you need to do, but it will put you in the right direction. All right, good luck.